Hello guys, today we'll be looking at binomial distribution. What did I say? Binomial distribution. It is also one of the discrete probability distribution. Now, binomial experiment and Bernoulli experiment are involved for two possible outcomes. But the difference between binomial experiment and Bernoulli experiment is that a binomial experiment is an experiment that consists of a finite repeated Bernoulli trials. So any experiment that consists of finite repeated Bernoulli trials is called a binomial experiment. What did I say? Any experiment that consists of finite repeated Bernoulli trials is called binomial experiment. Now let x be the number of sources. Let x be the number of sources in the independent Bernoulli trial. Now x is said to follow a binomial distribution with parameter. So let me write it down. Let x be the number of sources in the independent Bernoulli trial, x is said to follow binomial distribution with parameter n and p, with parameter n and p. Then x is said to follow a binomial distribution with parameter n, p if the probability mass function p of x equal to small x is equal to what? N combination x, p raised to power x, q raised to power n minus x, where x is equal to what? 0, 1, 2, n. This is the range of what? X. So x is said to follow a binomial distribution with the parameter n and p if the probability mass function p of x is equal to what? N combination x, p raised to power x, q raised to power n minus x. So that is it. Let's look at the expectation, variance, and the moment generating function of a binomial distribution. The expectation, variance, and MGF, which is the moment generating function of a binomial distribution, are NP, NPQ, and P exponential t plus Q raised to power n. So we are going to be proving how the expectation of S of a binomial distribution is equal to NP, and how its variance is equal to what? NPQ, and its moment generating function is equal to P exponential t plus Q all raised to power what? N. So let's start with the expectation of X. expected value of x is equal to what? Summation as x run from what? 0 to what? N. X run from 0 to n because it is a what? A binomial distribution of x multiplied by what? Probability of x equal to what? Small x. And we define the probability mass function of a binomial distribution to be equal to probability of x is equal to what? N combination x, which is equals to n combination x p raised to power x q raised to power n minus x. So putting it in this, we have the expected value of x is equal to summation as x equals to 0 to n of x multiplied by n combination x p raised to power x q raised to power n minus x. So, you know, this is also another way of writing combination. So this n combination x can also be expressed as what? N factorial all over what? X factorial n minus x factorial. So this is the short form of writing n combination x. So let's expand this. We have expected value of x is equal to summation as x equals to 0 to n of x. I told that this is equal to what? N factorial all over what? X bracket x minus 1 factorial n minus x factorial times what? P multiplied by p raised to power x minus 1. P raised to power x is also the same thing as what? P times what? P raised to power x minus 1. If you multiply this negative sign will go. So this is also the same thing as what? This, which will give us q raised to power what? N minus what? X. N bracket n minus 1 factorial. So this x, we cancel this x. So you have what? If you bring this p and n out of this bracket, you have expected value of x to be summation as x equal to 0 to n of, let's bring the np out of the bracket, np summation as x equal to 0 to n of n minus 1 factorial all over x minus 1 factorial n minus x factorial p raised to power x minus 1 q raised to power n minus x. Now from the property of a proper PDF, the sum of these from here to here is equal to what? 1. That's what makes it a proper PDF. The sum of any probability mass function or probability density function is equal to what? 1. So if this is equal to 1, you have that expected value of x to be what? Np multiplied by what? 1, which will give you Np. So that is how our expected value of x of a binomial distribution is equal to what? N multiplied by what? P. Where n is the what? The number of trials, and the p is the probability of success. So let's look at what? How the variance of a binomial distribution is equal to NPQ NPQ. So the variance of x is equals to expected value of x squared minus expected value of x all squared. This is what how a variance of x is being defined. Variance of x is equal to expected value of x squared minus expected value of x all squared. So if you're finding difficult how to prove or to show why the variance of x is equals to this, you can drop it in the comment section. I will put you through. So variance, let's first of all get what expected value of x squared. For a binomial distribution, we have that expected value of x squared is equal to summation as x equal to 0 to n of x squared multiplied by what? Multiplied by probability of x equal to what? Small x, which is a summation as x equal to 0 to n of x squared multiplied by what? N combination x p raised to power x times q raised to power n minus x. So this will give us summation as x run from 0 to what? N x squared n bracket n minus 1 bracket n minus 2 factorial. If you expand this, which is equal to all over x. Okay, that's good. Expected value of x, we know that x squared is also the same thing as what? X bracket x minus 1 plus what? X. So x squared is also the same thing as what? X bracket what? X minus 1 plus x. So since our expected value of x squared is equal to expected value of x bracket x minus 1 plus expected value of x. So let's get the expected value of x bracket x minus 1. So the expected value of this animal, expected value of x bracket x minus 1 is equal to summation as x run from 0 to n of x bracket x minus 1 probability of x equal to small x, which is equals to summation as x run from 0 to n of x bracket x minus 1, and we already defined this to be equal to we already defined this, the probability density, the probability mass function of a binomial distribution to be n combination x p raised to power x q raised to power n minus x. So if we expand this, we have equal to summation as x run from 0 to n of x bracket x minus 1, which is n. If we expand this n factorial, we have n minus 1, n minus 2 factorial all over x bracket x minus 1, x minus 2 factorial, n minus x factorial multiplied by p squared multiplied by what? P raised to power x minus 2. So this is also the same thing as what? This. So I put this p squared because I'm trying to hold, I'm heading somewhere. So p squared multiplied by p raised to power x minus 2 we also give you what? P raised to power x multiplied by q raised to power n minus 2. So this we cancel this. Okay, this is a constant, this is a constant. You can break out of the summation. So we have this is equal to n bracket n minus 1 p squared summation as x run from 0 to 1 to n of n minus 2 factorial all over x minus 2 factorial n minus x factorial p raised to power x minus 2 times q raised to power n minus x. So from the property of a proper PDF, a proper PMF, which is the proper probability mass function, the sum of the probability mass function is equal to what? 1. So from here to here, from this place to this place is equal to what? 1. And since this is equal to 1, we have that expected value of x bracket x minus 1 is equal to what? N bracket n minus 1 p squared. Okay, we have gotten the first part. So our expected value of this is equal to this. So our expected value of x squared is now equal to n bracket n minus 1 p squared plus the expected value of f, which we have already proved to be what? N p. So let's open this bracket. We have what? This is equals to n squared p squared minus n p squared plus n p. This is our expected value of x squared. But we are trying to show, we are solving for variance, and we defined our variance of x to be expected value of x squared minus expected value of x all squared. So this is the formula for variance. So we have, this is the expected value of x, we put it here, we have n squared p squared minus np squared plus np. So our expected value of x is equal to np. If you square it, you have what? Np, n squared p squared. So same minus np squared. So this, we cancel this, we now have what? Our variance of x to be np minus np squared. So what is common here? We have np to be common. We have this is equal to np bracket what? 1 minus p. And we defined 1 minus p to be what? Recall that that 1 minus p is equal to what? Q. So the variance of x is equal to npq. Proved. Okay, let's go to moment generating function of a binomial distribution. Moment generating function of a binomial distribution before we start solving examples. Moment generating function MGF of a binomial distribution. Binomial distribution. Okay. We define our MGF mx of t to be expected value of exponential t x. So this is how we defined the moment generating function. Now the MGF of a binomial, the expected value of this is equal to expected value of exponential tx is equal to summation as x run from 0 to what? N of exponential tx n combination x p raised to power x q raised to power n minus x. So what did they have in common? P and exponential t has x in common. So we have what? This is equal to summation as x equal to 0 to n of p exponential t raised to power x n combination x p raised to power n minus x. This is equals to summation as x equals to 0 to n of n combination x p exponential t raised to power x p raised to power n minus what? X. But in mathematics, binomial expansion helps us to know that if you have a plus what? B raised to power what? N. If you have, in mathematics, you have that a plus b raised to power n is also the same thing as summation as x equal to what? 0 to n of what? N combination x a raised to power x b raised to power n minus x. Mathematics made us to know that this is equals to this. Now, relating this into this, if you relate this to this, you now have that the sum of this, the sum of summation as x equal to 0 to n of n combination x p exponential t is raised to power x multiplied by q raised to power n minus x will give us, if you relate this to this, we now have that our mx of t is equal to what? P exponential t plus q all raised to power what? N. This is how our moment generating function of a binomial distribution. Thank you. Our next class will be solving examples on binomial distribution.